All right, if you're watching this, hey guys, hope you enjoyed the past 2 snow days. I wanted to show you guys real quick just what I want you to do today. So first of all, we didn't get to talk about this in class. We haven't had class the past 2 days. But one thing we're going to start doing is we're going to start doing the Unit 1 progress checks, okay? Now, these are for credit in class, but they are based on completion, not accuracy. I'll say that again. They're based on completion, not accuracy. And you know, I have 3 problems. Really, I think there's 15 by Friday, so this week you might want to do 5 and 5. That way, I'll just go and change it now, so you'll see that later, and there'll be 5. Yeah, the deal is with these, I really want you guys trying them on your own. I don't want any temptation to cheat or use outside materials because this is going to give you an accurate picture of what you know and what you need to practice, okay? So complete these on your own power. Don't ask for any help and don't use your notes. Try to do it on your own, but I'm giving you 100% if you just finish it, okay? Now, the actual grade there will tell you what you need to practice, and you might need to look at that and think about that, especially if you're planning on taking the AP test. But I want these to be low stakes, and I want you just to work and do these on your own. So that's going to be, I think we're going to have 1 a week that will break down into 3 problems a day, which I don't think is an overwhelming amount to add to our workload currently. Please let me know if you think otherwise. But this week will be 5, 5, and 5 because, they don't always have 15. They vary how many there are, okay? So make sure you click on that link. Do that. That's in AP Classroom, and it records as you go, so make sure you log in with your account information and all that. But what I want to show you guys now is we're going to do video notes on this assignment here, which we were going to do in class. This is an FRQ. It's a practice FRQ, so it's not actually the one that you find if you go online, but it is calculator active, so go ahead and grab your calculator. There'll be a few things I'm going to get you to do, okay? So let's start reading through this. So this is at time t equals 0 minutes. A tank contains 100 liters of water. The piecewise linear graph to the right here shows the rate R of t in liters per minute. So right away I see some things. I see that this is a graph of rate. Okay, it's shown there and shown there, right? So you can think of this, I think of this as a first derivative, right? And it's a first derivative of what? It's the first derivative of the number of liters in the tank, right? And so, so this is the rate which water is pumped into the tank during a 55-minute period. So you see you've got minutes along the x here. First, they want us to find R prime. So this is the derivative of the rate. So in other words, it's how fast the rate is changing. Okay, so let's explain the meaning of your answer in context. Well, we can go ahead and type that down, right? That's going to be, so part A here, R prime is the rate that the rate is changing. In other words, and this is a better way to answer this would be how fast the rate of water entering the tank is changing, right? So let's calculate that, and maybe this will make a little more sense once we actually have a number to put to it. So we're asking for R prime of 45. 45 shows up right there. And so that's somewhere on this line. Now we don't know exactly where, but it doesn't matter because the slope of a line is the same throughout the entire line. So we find the slope of that line, we've got R prime, right? So what do? Well, we need to do y2 or y1 minus y2 all over x1 minus x2. You could do 55 minus 35 on the bottom as long as you do 0 minus 30 on the top. And when you calculate that, you get negative 3 halves. Now, what are the units? Well, this is liters per minute, okay? So liters per minute, we can just do this per minute, in other words, per minute squared, okay? So if it's per minute squared, what does it mean? This represents how fast the liters per minute is changing, okay? How fast the rate of the water is entering the tank is changing. And so since it's negative, it's saying that the rate is decreasing, and that makes sense. Up here, this whole time period, it's entering at 30 liters per minute, and it decreases down to 0. So this whole time, that is decreasing. So that answer makes sense. Great. On to part B, how many liters of water have been pumped into the tank from 0 to 55 minutes? Show the work that leads to this answer. Well, we can write that as the integral from 0 to 55 of R of t. All right, so R of t, here we go, dt Yeah, RT, yep. So, and how, like, okay, so then we don't have an equation, so what do? Well, remember, that's the area under the curve. So I'm looking here, I'm going, all right, we want this area here. So let's break this up into parts that we can find geometrically, right? So I'm seeing this is 20 there. This is 35 right there. And so we have a trapezoid, we've got a rectangle, we've got a triangle. The important parts are going to be, this is going to be a height of 10, a width of 20, and a height of 30 there. This is going to be a height of 30, a width of 15, and a height of 30, of course. And then this is a height of 30 and a width of 20 there, because 35 to 55. So go ahead and take a moment to calculate the area of those three shapes and add them together and find out what you get. All right, hopefully you got all that. So how do I do this? Let's see here. 10 plus 30 divided by 2, this is a trapezoid, so you do the average of the two bases, though I know they're on the sides, but the bases that are different lengths, multiplied by the width, 20, plus our rectangle is going to be 30 times 15, plus formula for a triangle is 1/2 base times width, so 1/2, 20 times 30. And when you add all that, punch that in a calculator, I get 1,150, and the units are going to be liters. It's liters because liters per minute is the line, but underneath that is going to remove the minutes, right? So just liters. All right, part C. At time t equals 10 minutes, water begins draining from the tank at a rate modeled by the function. So we have a function here. Remember, this is calculator active, so you don't have to stress about, oh no, we have to take the derivative or integral of that. No worries, it's calculator active. Water continues to drain at this rate until time equals 55 minutes. How many liters of water in the tank at time t 55 minutes? So what's going on? Well, let's see. Well, a few things. First of all, at time 0, we need to recognize this. It starts off with 100 liters of water, okay? So we're starting at 100 liters. This graph shows us how much it's increasing, right? And fortunately, we just calculated that, right? So I can put plus the integral from 0 to 55, r of t dt. We know that that number is 1,150 liters because that's been added. But here, this keyword here is draining. It's draining from the tank. So we're going to subtract this amount. Now, what is this? This is a rate again, right? So how are we going to calculate how much there is over time? We need to take the integral. And it says it starts draining at 10 minutes. So we need to start at 10 minutes and go to 55 minutes there. So I'm going to write this down, 10 e to the sine of t over 10 and dt. Yep, there we go. And that right there is going to tell us how much water, how many liters of water in the tank at 55 minutes after all this happens. So what are we going to do? We're going to punch this into the calculator. Let me get my calculator. All right, so I've got the 100 plus 1150 minus, I'm going to go to math integral, that's 9, fn int, and from 10 to 55, whoops, of 10 e to the, I'm going to actually even use this. If you have an older calculator, you'll need to use parentheses in that part right there so that they know all that's in the exponent there. And I chose x. You could choose t. Just make sure whatever variable you put up there, you get at the end there, and we press enter, and we get, oops, let me put this on the screen. Oh, it's thinking. See, it's thinking right there. 799.724 or 725. So let's go ahead and write this down here. Whoop. Equals 799.724 or 5. Of course, I'm writing this down. Make sure you don't write it like that on the test. Only write one of those two numbers. All right. And how many liters of water in the tank? That is going to be liters. Part D. Using the functions RD, determine whether the amount of water in the tank is increasing or decreasing at time t equals 45. Justify your answer. So what do we need to do? Well, what we need to do is we need to calculate r of 45 and d of 45. And that's the rate. So if the rate of it increase, if the rate of the flow into the tank is higher, if it's like this, then it's going to be, the water in the tank is going to be increasing. If D, the amount draining, that rate is faster, is higher, sorry, if that rate is higher than the rate of water increasing, then it's going to be decreasing, right? It's as simple as that. And you want to make sure you recognize these are the rates already. You don't need to take the derivative or the integral or anything. You're simply comparing R of 45 and D of 45. So R of 45, how do we get that? And then I'll show you how, and then I'll let you have a shot at it. R of 45 is halfway between these, right? So we're at 45 here. There's a few things we could do. We could find a formula for an equation here. We already found the slope earlier, right? That's this amount here. And we found a point. You could plug in that into point slope form, and you can plug that in and get that slope directly from there, right? Once you plug in 45 for x, then you calculate y. Another way to do that is you could also recognize that this right here is 35. This is 55, so 45 is going to be halfway between those. And since this is a line, this only works for lines, right, not curves. So this is a line that's going to be halfway between this value and this value, right? The y values are the point we find is halfway between them. So you can calculate that as well. Go ahead and take a minute to do one of those two methods. All right, you should have gotten R of 45 equals 15. That's the rate at 45. And then for D of 45, we're going to simply plug in 45 into this equation. So I'm going to go grab my calculator and I'm going to type that in. Go ahead and take a minute to calculate that. All right, I plugged that in here. Notice I got 10e to the sine of 45 over 10. One comment, make sure that this is in radian mode. When otherwise specified, it's in radian modes. So that might be why you're not getting the same numbers as me here. But 10.889, so we come back here. 10.889, and since R of 45 is greater, we say that what? The amount of water in the tank is increasing because the rate that it's entering is greater than the rate that it's decreasing. That's leaving. So we can even write something like this. This helps. There we go. All right, so I plugged that into the calculator here. Make sure you're in radian mode, right? Unless otherwise specified, it's in radian mode. And 10.889 is what I got. 10.889. So that means what? The amount of the water in the tank is increasing because the rate that it's entering the tank is greater than the rate that it's leaving the tank or draining the tank. All right, thank you guys for watching.